Okay, so is there any problem from last week? If no, then we can. Do you have any problem from the last class, or you can start from the today's class? And I told you people that I will share some important notes about the vector calculation as well as that second order differential equation solutions. So I could not do that one, but obviously I will just upload that one maybe this week. So that will be helpful for you people. So basically I will focus on that second order differential equations law, because in that last class we were discussing about some second order differential equations which was like some of the people did not understand clearly. So it may be possible that it is totally new for them. So I was promised that I will just explain. I will just give a note on that about the differential equation solution rules. So, but I could not upload that one in my Google Drive. So today or at the most tomorrow I will just upload these things. I have to write that one and I will just make a PDF and I will just upload that one in Google Drive. So yeah, that is there, and I think all of you got the Google Drive link where I am just posting each and every week's PDFs. And if not, then I can give you one link right now as well. This is the one, so I'm just giving you the link here in the chat box so that you can see that. This is the chat box, and in the chat box you can see the link. Okay, now coming to the PPT again. So today we will basically focus on the things like what we will talk today for the school. And this is obviously the first week questions. You can see that this is the assignment 1 or week 1 questions, and we could not finish that one in the last week. So maybe we will just do a little calculation, a little recap of the first week, whatever we left, and after that we will go for the second week questions. And if you have any doubt on that second week questions in this year's assignment or the first week assignment problem, then you can just directly ask me. There is no problem on that. So yeah. So now today we will basically focus on that divergent the questions. Okay. So the first question we have already discussed in the last class, that divergence of r vector by r cube. What is the value of this one? So we have already calculated and we got the result of this one as 0. So you can see in my previous lecture also where we were discussing the values of these things and how we can calculate this. So we just calculate like that one, and we just use the expression of this as let's say 5, then divergence of a plus grad 5 plus e. So this type of things we calculated, and then we found that it was at the very first minus 3 by r cube or something. Maybe I can write like that. So as a whole it is coming as 0, I think. Yeah, so divergence of 3 by r cube minus 3 by r cube, it is coming as like that, and it is coming as 0. So that one was already done in the last class. So now we can go for the second question. If you have any doubt, you can ask me from the last week or last class questions, so whatever we have discussed till far. And or if there is no question, then we can go for the today's class. So I think I am audible. Yeah, my video got stuck, but fine. So yeah, so today we will basically focus on the second question. From the second question we will start, and okay, let's start. So today's second question is this one, exactly the similar one, but in the previous one it was divergence of r vector by r cube, and now it is curl of r vector by r. So curl they are asking. So curl will be like, if I want to write it like phi I cap, then what will be the answer, and I have to calculate the value of this one. Okay, so but this case as in that similar to this one, I just want to expand this expression something plus something. And obviously in the previous class also I told that you no need to remember the expression, so but you just only need to remember one six commands, and the 6 commands I am going to write here again, so that you can just remind yourself very quickly. So what was the statements I was just telling in last class? The last class statement was like divergence of del. Del operates on scalar, divergence operates on vector, curl operates on vector. So these 3, and diverge grad phi results vector, divergence of A results scalar, curl of A results vector. So these 3 and these 3 we discussed in the last class obviously, and these 6 statement, if you remember, then you can calculate or you can expand any of the vector calculus laws very quickly. So here you can see that I was telling that curl of phi A. So curl of phi A means that will be obviously a vector, because curl of something will give a vector form. So whatever this portion and this portion, both two should be a vector one. So I am not going to explain all these things here, because in the last class we already explained very clearly. So now I am just going to write the expression for this curl of phi A. So it will be simply phi, then curl of A, and here it will be grad phi cross A. So this will be answer. This will be the expansion for this case, right? Because both you can see both of these something plus something will give us a vector form. So if I just follow this notation, then it will come as like curl of r vector by r cube, and I am going to write it as like phi A vector. So it is like coming as, let's say, 1 by r cube, then curl of r, then plus grad of 1 by r cube cross r vector. Okay, so this we are getting. So then if I calculate these things, you can see that 1 by r cube is fine, but curl of r vector is going to be 0. So if you can't understand that curl of r is going to 0, then I can just explain that one as well. But first let me write here. So curl of r is giving 0 vector. So plus then 1 by, gradient of 1 by r cube. So gradient of 1 by r cube is giving minus 3 by r to the power 5, then r vector, then cross r vector. Now you can understand r vector cross r vector is also giving 0. So that means this is coming as 0 plus 0, which is coming as 0. Okay. Now you can ask me that curl of r vector is giving 0, how we can say that? So it's very simple, that if I want to write here curl of r, so curl of r means what? I am just going to calculate the curl. So here r is like x, y, z. This is I cap, z cap and k cap. Sorry. So this is del x, this is del y, this is del z, and then x, y, z. Okay. So now you can see our I cap. If I want to calculate the I cap value, then it will be like del y of z minus del z of y plus j cap del z of x minus del x of z plus k cap del x of y minus del y of x. So you can understand that all the 3 terms are coming as 0, because this is a partial derivative. A partial derivative with respect to y of z, partial derivative of y with respect to z. These all are coming as 0. So as a whole, the answer will be 0. So obviously you can see that curl of r vector is equal to 0. So now the value of this one is coming as 0. Okay. because both terms are coming as 0, so that means our result will be 0. And r cross r, how it is coming as 0? Because x I cap plus y j cap plus z k cap, then cross x I cap, y j cap, z k cap, right? So it is like a x square I cap cross I cap. So I cap cross I cap, so I cap cross I cap will come as 0. I cap dot I cap is coming as 1, but I cap cross I cap is 0. Now you can see, you can tell me that this one will come, like let's say x y I cap cross j cap. Yes, that will come. So it will be like that so it will be like k cap. But another one will come as, let's say, j cap cross I cap. So j cap cross I cap x y, j cap cross I cap will also come. So that will give me x y minus k cap, because j cap plus I cap is giving us minus I cap. So x y k cap minus x y k cap. So that means it will come as 0. Similarly, all other terms will come, some values which will be cancel out the other combination. So like let's say y cap plus y cap will, j cap plus j cap will come as 0. But j cap plus k cap means y z j cap plus k cap. But again, I will have another one where z y k cap plus j cap. So if j cap plus k cap equals to minus of k cap plus j cap, and yz and zy are exactly same because this is a simple multiplication of two scalars, so then I can have a 0 value. Similarly, I cap plus k cap and k cap plus I cap, these will also give me a 0 value. So as a whole, r vector plus r vector will give me a 0 value. Okay, so this is the case. So the answer question number 2, that the value of the curl of r vector by r cube will give me a 0 value. Okay, now coming to this point. This point is what? For a conservative vector field, which of the following statements are true? Okay, so conservative vector field means what? Let's say I am talking about f. This is a conservative vector field. Conservative vector field. Okay, so if it is a conservative vector field, then what will happen? First of all, there is some criteria to be a conservative vector field, like f should be a conserved one. So if is a conserved quantity, then it should follow some criteria. The first criteria is curl of f should be 0. F can be written as minus grad of v, where v is a potential. How we can write it? I will tell this. Basically, curl of any vector will give us 0. That is a simple vector calculus. Okay, so this is a vector calculus. So vector calculus is telling that curl of grad v should be 0. Now, as I told you that for the calculation of conservative vector field, curl of f equals to 0. So then we can write it like, and also we can write here it is like minus grad v. That can also be fine, because minus we can just combine it out and it will come as 0 again. So if I just compare these two, then I can have that f equals to minus grad v. So this one is a equation for that conservative field, and curl of f equals to 0, that is also equation for that conservative vector field. And okay, now coming here, the field must have curl 0. That means, as I told, curl of f equals to 0. That means this one is correct. The field must have 0 divergence. This is telling that this should be 0. But in to get a vector field as a conservative vector field, we don't need to follow this rule. So divergence of f equals to 0. It is it should not. It is not a necessary condition to be a vector field as conservative vector field. So this one will not be the correct one. This one will be correct one. The work done in moving a particle between 2 points is positive, independent. So that one I will just come a little bit later. But let me first here. The field can be written as the gradient of a scalar potential. So the field can be written as the gradient of a scalar potential. That what I was telling, that F can be written as minus grad V. So the field, that means V, can be written as a gradient of a scalar potential. Yes, that is also true because we have already checked that one, that F can be written as minus grad V. How we have checked that one? You can see here that curl of a grad of any vector, any scalar, will give you a 0 vector. So that means as also curl of F equals to 0. So by comparing that one, F can be written as minus grad V. So that is also correct. Now coming to the total mechanical energy of a particle in this field is conserved. So total mechanical energy. Total mechanical energy. Obviously, total mechanical energy, if I write here this one as total mechanical energy. So total mechanical energy from the energy conservation law, it should be conserved. That means let's say E1 equals to E2. For all the cases, all the system, our mechanical energy should be conserved for any of the particles in this field. And now coming to the work done in moving a particle between 2 points is path independent. Yes, that is also true. How it is true? Because the work done is F dot dr integration. So basically, if our field is a path, if it is a conservative vector field, then it should not depend on the path from how we are going A to B. Wherever I am just going from here to here, in this path, here to here, in this path, here to here, in this path, in every path, our work done should be same if our F is a conservative vector field. So as this is a path independent function, so whenever we will go from F dot, if it is a, if it is a conservative vector field, if it is a conservative vector field, you can check that F dot dr in any path, like let's say from here to here, in any path, from here to this point, from then to this point, from here and then this point, only it will give a same value of work done, only it will depend on the initial value and the final value, initial point and final point. So it does not bother about that in which path I am going from A to B. I can go from here to here in that path, here to here in that path, here to here in that path. It does not matter what will be the how I will go for A to B, but the result will be exactly same for all the paths of that work done. So this is also correct. The work done in moving a particle between 2 points is path independent. So now I can write a little bit a simple function, like formula. Like formula means like it's a very take home message you can tell. So how many, let me write here, how many criteria I have. So if F is conservative vector field, so conservative means first of all you will just think that if curl of F equals to 0, always put a vector from here, and basically it is already written as that this is a vector field. Okay, now as it is curl of F equals to 0, then F can be written as minus grad of phi, where phi is the potential, phi, V, whatever you can write. Then total mechanical energy, is always conserved. And another one is W, which is F dot dr is path independent. You can see that one from any of the calculations. If F is a conservative vector field. Okay. In a three-dimensional space, if the force is given by this, then the corresponding scalar potential function V is how much? So first of all, I can write it F as Kx I cap plus Ky j cap plus Kz k cap. Right? And I will basically focus that whether F is conservative or not. If F is conservative, if F conservative, then I can write f equals to minus grad v. Otherwise I can't write it as minus grad v. So we have to first check that whether f is conservative or not. So let me check that f is conservative or not. So how to check that? Obviously for checking f as conservative or not, I will just do that curl of f equals to 0. So curl of f means I cap, j cap, k cap, then del del x, del del y, del del z, kx, ky, kz. Now you can see that if I will just do the curl of f, then it will come as like for I cap. Okay, I'm just writing for I cap. Del kz, del y minus del ky, del z plus for j cap, del ky, del z minus del kx, del x, del kz, del x plus k cap, del ky, del x minus del kx, del y. Okay. So if I calculate these things, kz means it's a function of z only. So there is nothing as del del y of kz. So it will come as 0 minus 0 of I cap. Similarly, all the terms are 0. So that means curl of f equals to 0. Now if I can get that curl of f equals to 0, that means I can definitely say that f is conservative. Okay, so f is conservative. Now if f is conservative, then I can write it like this. So del v, del r. Now what will be the value of f? V. V, they are asking that what will be the value of v as a function of x, y, z. So I am writing here v as a function of x, y, z, which will be like simply f dot dr. Because the derivative was f equals to minus del v del r, so v will be f dot dr. So and f is what? F was kx I cap plus ky z cap plus kz k cap. Dot dr was what? Dx I cap, dy j cap, dz k cap. Now you can see I can write it like I cap will be 1 and I cap dot j cap, all the combination will give us 0. So that means kx dx plus ky dy plus kz dz. Okay, and another thing was here it is minus, so that means our v will be minus f dot dr, because f was minus del v del r, right? So v will be minus in relation of f dot dr. So it will come as minus and then minus. So it will come as like kxx plus kyy plus kzz, and then there will be a constant. So this is the answer. So now we can just compare that one. You can see if I just do this one, minus of this plus then constant. So it is like minus of kxx plus kyy plus kzz plus constant. So v will be this one, kxx plus kyy plus kzz plus constant. So the answer will be C. C or D? No, C. So this one is the correct answer. Okay, so this is the mathematics for a three-dimensional vector space. If the force is given by this, then the corresponding scalar potential function v is xyz in terms of the is 1. So this question will be only valid if f is conservative. Then only I can write it f equals to minus grad v, and v I can write it f dot dr. Then we can write a dr equals to dx I cap plus dy j cap plus dz k cap. Okay, so these are the things. Okay. Okay, so this is a little bit tricky question, but it's very simple, good question. So now coming to the question number 5. A particle moving in one dimension means obviously there is maybe only x dimension is there, only x is there. Y and z dimension is 0. Loses mass at a rate proportional to its instantaneous mass. This is the important one. So what does this mean? This means that dm dt at a rate. What is the rate? Proportional to its instantaneous mass. That means dm dt is proportional to m. It loses its mass at a rate proportional to its instantaneous mass. Actually, if it is loses, that means I have to write here a minus sign. So, because the value is getting decreased, right? So, dm dt is equals to, I can write is minus km. Okay? So, if dm dt equals to minus km, this expression I got. Okay? Now, another thing. If there is no external force, that means our f is 0. So, if f is 0, I can write f as dp dt. So, ddt of mv. Now you can see here, if I write ddt of mv, I can just expand that one as m dv dt plus dm dt then v. So now you can see m dv dt is fine, then dm dt was what? dm dt is minus km. I can just replace that one by minus km then v vector, which is equals to 0. Why 0? Because you can see that the total force is 0 and the total external force is 0. That means this one is coming as 0. So, m dv dt minus kmv equals to 0. Now, it can be cancelled out. So, dv dt minus kv equals to 0. And what they are asking? They are asking that what is the velocity vt as a function of time? Assume the proportionality constant is k. So, I have already checked that one as k. So, dv dt equals to kv. Then I can just write it like that, k dt, and then integration of dv by v, integration k dt plus, let's say, ln c, and constant. C is constant. Okay. Now this is ln v, and this is k into t plus ln c. Now at t equals to 0, let's say our v is v0, any constant. So ln v0 equals to 0 plus ln c. So I can write c equals to v0. So ln v equals to k into t plus ln v0. So you can see ln v minus ln v0 equals to k into t, and v by v0 equals to e to the power k into t, v equals to v0 e to the power k into t. Actually in the question it should be a plus 1, because it is saying that it is losses its mass. If it will tell that it will gain its mass, then it will be a plus km. But as it is losses its mass at a rate proportional to its instantaneous mass, so that means v equals to v0 e to the power I e to the power kt. Okay, so this is the final answer. So our v will be v0 e to the power k into t. But if let's say dm dt is equals to only km, then it will come as v equals to v0 e to the power minus kt. You can just check that one. But as it is a loss function, so that means there will be a again minus sign, so that means here it will be plus sign. Okay. So now coming to the next question. Particle starts from origin with 0 velocity. Okay, very good. It is telling that at t equals to 0, origin means t equals to 0, our velocity of the particle is 0. if its acceleration vector is given by at 0.5 t square I cap plus 3t j cap. Okay, this is acceleration. So acceleration is what? Acceleration is dv dt. So this is 0.5 t square I cap plus 3t j cap. Now what is vt? It will be simply integration of this one. Okay. Dt. So it will come as 0.5 t cube by 3 plus 3 t square by 2 plus c1. So c1 is what? As I told you that v at 0 is 0. So if I put t equals to 0, that means our left hand side is 0 and this is 0 plus 0 plus c1. So c1 will be also 0. So v of t is simply 0.5 t cube by 3 minus 3 by plus 3 by 2 t square. Now, if it is v, then what they are asking? They are asking that what is the position vector at t equals to 2 seconds. So position vector means v can be written as dx dt. So dx dt is equals to 0.5 t cube by 3 plus 3 by 2 t square. Then what will be the value of x of t? X of t is simply 0.5 t cube by 3 plus 3 by 2 t square dt. So it will coming 0.5 t to the power 4 by 4 into 3 plus 3 by 2 t cube by 3. Okay, plus c2, let's say, another constant. So, but at t equals to 0, as v equals to 0, then x will also be 0. Right? Because x is a function of t. So, you can just write here c, x equals to 0, then 0 plus c2. So, c2 will also come as 0. Now, I can write it xt as 0.5 into t to the power 4 divided by 12 plus 3 by 2 t cube by 3. So I can write it like 0.5 t to the power 4 by 12 plus 1 by 2 t cube. Okay. Oh, sorry, I cap j cap was there. I forgot to write the I cap and j cap. This is I cap. This is j cap. By 2. So it is I cap, it is j cap. 0.5 t cube plus 3 by 2 t square. Okay. 0.2 to the plus 3 by 4. This is I cap. This is j cap. 3 by 2 to the plus 3 by 3. So it will be coming as I cap. This is j cap. This is I cap. This is j cap. Now they are asking that the position vector at t equals to 2. So position vector at t we got. So x of t we are getting as 0.5 t to the power 4 by 12 I cap plus half t cube j cap. Now at t equals to 0, that means x of 2 I am getting 0.5 divided by 12 into 2 to the power 4. 2 to the power 4 is 16 I cap plus 1 by 2 into 2 to the power 3 is 8. So it will be coming as 443 2 by 3 I cap plus 4 j cap. Okay. So x2 is 2 by 3 I cap plus 4 j cap. 2 by 3 I cap plus 4 j cap. So this is answer number 2. Okay. I think this is clear to all of you. Okay. Coming to question number 7. The question number 7 is telling a particle is moving along a straight line. A particle is moving along a straight line in the xy plane. So that means if I talk about x and y plane, in that plane the particle is moving. So if particle is moving in the straight line or in the xy plane, that means let's say the position vector of the particle is, let's say, something. Position vector means I should write here r vector. So it is like something a I cap plus b j cap. It can be like that. Which of the following conditions can be true? Okay. The particle is moving with constant acceleration in both x and y directions. Okay. So if let's say I am writing here r of t, which is a function of a of t I cap plus b of t j cap. Now let's say I am writing here r vector as a very simple example. Okay, so if it is like let t to the power 4 I cap plus 4 t to the power 5 j cap, like that. So constant acceleration in both x and y directions. So constant acceleration. Acceleration is what? Acceleration is like okay. So for acceleration, it should be dr dt is equals to velocity. So 4 t cube I cap plus 20 t to the power 4 j cap. No, I should write here square. This is also square. Just take an example of like this. So our v will be now. Our v will be 2t I cap plus 8t j cap. Now what is dv dt? dv dt as a, which is 2 I cap plus 8 j cap. Now we can say ax is 2 and ay is 8, right? So the particle is moving with constant acceleration in both x and y directions. So ax is also there and ay is also there, and both are time independent. That means this is a constant acceleration. So this one it can be correct if our position vector is like that. We don't know what will be the position vector, but it is saying that the position vector is in xy plane. So if it is in xy plane, so that means I can write rt vector is like as a simple example, t square I cap plus 4t square j cap. If I can write it like that, then ax equals to 2, ay equals to 8. Okay, which is giving us that particle is moving with constant acceleration in both x and y directions. Okay, this is correct. Now the particle has force acting only in the x direction. Okay, whether it is correct or not, I can take another example of RT. Okay, RT, it can be written as like t square I cap plus 4 t j cap. I'm just taking an example of that. So if it is like that, then I can write here dr dt, which is v, that will be 2t I cap plus 4 j cap. Okay. Now our force is what? Like okay, I should not write it like that. So force is like ddt of mv, and if I am taking m as like let's say constant value, then am dv dt. So am dv dt means you can write here 2 I cap plus 0 j cap. So I can write here 2 m I cap. That means you can see our force is acting only in the x-axis. So I am having fx is only. So if I will choose our r vector is like t square I cap plus t j cap, in something like that, then the particle has force acting only in the x direction. So that is also correct. The particle is experiencing zero net force. Okay, let me check this one. zero net force. Zero net force means what? I am taking here, let's say, r vector as let's say 4 t square I cap minus 4 t square j cap. So again dv dt I am just calculating. It is like 8 t I cap minus 8 t j cap. Then dr dt v equals to dr dt. So it is like am dv dt. So am 8 I cap minus 8 j cap. So you can see our fx is 8 m8 and fy is minus m8m, right? Now the total net force is what? Like along x-axis it is coming as 8m and along y-axis it is coming as minus 8m. But as the total f is like 8m I cap minus j cap. So total net force cannot be a 0, 1, or it can be okay. For this case it will not come as 0, 1, but our, let's say, r of t is like something t I cap minus or plus 8 t j cap. So for this case dr dt equals to I cap plus 8 j cap, but f equals to dv dt, that is coming as 0. You can see that for here, for all the cases there is a not if dependency, so that means as a whole it will come as 0. So this can also be possible. So net force is 0. That can also be possible when our force particle position vector is, let's say, t I cap plus 8 t j cap or something like that. The particle has a non-uniform acceleration in both x and y directions. Okay, that is also correct. Why? Okay. So I am writing here, let's say this is like x, let's say t square I cap plus 9 t square j cap. If it is like that, then acceleration means dv dt. So dr dt to t I cap plus 18 t j cap, or let's say it is t cube and t square. So it is 3 t square and 18 t. Now dv dt, this is acceleration, that can be written as 9t I cap plus 18 j cap. Now you can see here ax is 90 and ay is 18. So you can understand that both are not same. Like it is a function of t and it is a constant value, so these two are non-uniform, right? So these ax and ay both can have a non-uniform acceleration, x and y directions. So all the options will be correct for the case of a particle is moving along a straight line in the xy plane. Okay. Now coming to here. So this is a very simple question. The question number 8, given a force field, a vector is given x square y I cap plus xy j cap plus yz k cap. Okay? Compute the unit vector along curl of f. So along curl of f. So first of all we need to calculate curl of f. So how to calculate curl of f? Simply I will just write here curl of f del del x del del y del del z x square xy yz. So you can write it del del y of yz minus del del z of xy plus j cap del del z of x square minus del del x of yz plus k cap del del x of xy minus then del y of x square. So I can have the value is like z I cap plus y j cap. So this is curl of f. Okay, so this is curl of f. Now they are asking that what will be the unit vector along curl of f. So unit vector along curl of f, I am just denoting that one as n cap. So it is curl of f by mod of curl of f. So it is zi cap plus yk cap divided by root over z square plus y square. So n cap can be written as zi cap plus yk cap root over y square plus z square. So let me check the option. Zi cap plus yk cap, it should be k cap, right? Yeah, it should be k cap. There is no y in j cap, so I have written correctly. Yes, I cap, k cap, and then root over y square plus z square. This one is the correct option. So what I did here, I just did the calculation of curl of f, and curl of f. After calculating curl of f, I just did the unit vector n cap as curl of f by mod of curl of f. So I will get z I cap plus yk cap divided by root over z square plus y square. So I can just remodify that one as z I cap plus yk cap divided by root over y square plus z square. So this is my n cap, unit vector. Okay. Now find the unit vector in the direction of the vector of a cap. Vector is given here and unit vector they are talking. So it's very simple. It is like a vector by mod of a vector. And a vector is what? 3, 4, 12. 3, 4, 12. So mod of a is what? 9 plus 4 square plus 12 square. So it will be 9 plus 4, 16 plus 144. Okay. So now you can see it is 25 plus 144. This is 169 and then it is 13. So our n cap is simply 3 I cap plus 4 j cap plus 12 k cap divided by 13. So let me take the answer. So 3 I cap plus 4 j cap plus 12 k cap and 1 by 13. So this is the answer. Find the unit vector in the direction of the vector a cap is 3i plus 4j. Okay. Now this is the question. This is a little bit lengthy question, but not that much. For a vector, for a force field, if 2x I cap plus 3y square j cap plus zk cap, find the work done along the path x equals to t square, y equals to t, z equals to sin t from t equals to 0 to t equals to 1. Okay. So first of all, I am just writing here f as 2x I cap plus 3y square j cap plus zk cap. And what is the expression for x, y, z? X equal to t square, y equals to t, z equals to sin t. Now, if I just replace x, y, z in terms of t, then it will be 2t square I cap plus 3 t square j cap plus sin t k cap. Right? Now, the find the work done. Work done means what? W is simply f dot dr. Okay, I can do one thing. First I can do 2x I cap plus 3y square j cap plus z k cap dot dx I cap dy j cap dz k cap. Yes? So now it will come as 2x dx plus 3y square dy plus z dz. Okay? Now x was t square. This was t square. Yes. Y was t and z was sin t. Now I can write as dx equals to 2t dt. dy is dt. dz is cos t dt. So w I can write is f dot dr equals to 2t square, then dx. dx is 2t dt plus 3 t square dt plus z was sin t cos t dt. Now you can just common all the dt terms, then it will be 4t cube plus 3t square plus sin t cos t dt, and they are asking w from t equals to 0 to 1. So I am getting the limit as well, and w is a scalar function, so obviously the answer will be a scalar one. There will be no I cap, j cap, k cap term. So the value will be t to the power 4 by 4 plus 3t square by t cube by 3 plus half of sin 2t, so minus cos 2t by 2 and plus okay, we will just take the limit, right? So it will be 1 plus 1 plus 1 by 4 minus cos 2 plus cos 0. Cos 0 is 1. So it is 2 plus 1 by 4, 1 minus cos 2. So if I just calculate these values, then it will come as like 2 plus 1 by 4 minus cos 2 by 4. It will be, I just calculated this value expression and the value of this expression, and it is coming as, let's say, something 2.354. So the answer was, you can see 2.354 was answer, so 2.3 approximately it is the correct one. Right? Yeah. Okay, so for this what I did, I just calculated f equals to this one, and x equals to t square, y equals to t, and z equals to sin t. So I just write here f in terms of this x, y, z in terms of t, and w is f dot dr. So if f dot dr is there, that means I have to calculate 2x dx plus 3y square dy plus z dz. Now dx dy dz, it should be in terms of t, because they have given me only the t equals to 0 to 1. They did not tell about the x, y, z limit. They have given only the t limit. So I just converted that one. Dx equals to 2t dt, dy is t dt, and dz is cos t dt. So then if I calculate these things, then it will come as w equals to, after simple calculations, putting limit is t equals to 0 to 1, it is coming as 2.354. And then the answer is this one. Okay, so I'm just going a little bit on this whole question, so that if you have any question, you can just ask me, or otherwise we will go for the second week, because it's already 1 hour and we left another 1 hour for our calculations, for our class. So this is the 10th question answer, and this is the question This is the 9th question. And this is 8th question. This is 7th question. For 7th questions, I just put each and every explanation. Like I just put in one example of all the points. Let's say for here, what I do this. T cube and 9 t square. T cube I cap plus 9 t square j cap. Then this is question number 6. And the answer. Then question number 5. Just make sure that that is a loose mass. If it is a gaining mass, then there will be a plus kn. Okay. Then this is answer question number 4. Question number 3. Question number 2. And question number 1 we were calculating there last class. Okay? So these are the questions. Okay, now maybe I can go for the next week. That means this week. Yes. So this week has again the 10 questions, and we will talk a little bit on these 2 questions. And I did not like right now I will not talk about any theory part, because if you have any doubt on the theory part, you can ask me. Otherwise, we will directly go for the answer question answer part. And okay. So the first question is, for a force field, if is given 3xy plus z square I cap plus x square j cap plus xyz k cap, which of the following is or are true? So which of the following is true? So if, okay, first of all, by seeing the options, we can see that they are asking that curl of f and divergence of f and phi. So curl of f, so we have to take the curl of f equals to 0 or not. F is conservative, that means again that curl of f should be 0. Okay, so first I will just check that whether curl of f equals to 0 or not. So curl of f, let me write here because it's a bit clumsy. For this I have so much space. Xy plus z square, 3xy plus z square, x square xyz, x square xyz. Okay, now coming here. So for I cap, it will be like xz minus 0 plus j cap to z minus yz plus k cap 2x minus 3x. Now you can see curl of f is xz I cap plus 2z minus yz j cap plus minus x k cap. Now from this I can get the answer that curl of f is whatever is there, it is not equals to 0. So as curl of f is not equals to 0, that means f is not conservative. And I told if f is not conservative, then f cannot be written as grad phi. or grad V. Minus grad phi, minus grad V, anything. So it cannot be written as like that. So curl of f is not equal to 0. So f cannot be written as a gradient of a scalar. This is true. And if curl of f equals to 0, that is not true. So we will not go here. Divergence of f equals to what? And this is also not correct. So divergence of f they are asking. Now calculate divergence of f. What is this? This is like this. What? 3xy plus z square. X square is square and xyz k cap. xyz k cap. Okay, so you can see the answer is 3xy plus z square plus del y x square plus del z xyz. It is like 3y plus xy. So divergence of f equals to 3y plus xy. But here it can see our divergence of f is 2x plus 2y plus 2z plus yz. So that is also not correct. Okay? So only the second one will be the correct option. Okay. Now coming here. 3 forces F1, F2 and F3 act on a particle in equilibrium. Find the values of A, B and C. So in equilibrium, let me write here. Net force is 0, means F1 plus F2 plus F3 equals to 0. Okay. So let me write here F1, F2 and F3. F1, F2, F3 were what? 1, 2, 1, minus 1, 1, minus 2. 1, 2, 1, minus 1, 2, minus 1. Now 1, minus 1, 1, minus 2, minus 1, minus 1, minus 2. Minus 2, right? Yes. A, B, C. And F3 equals to A I cap plus B J cap plus C K cap. So they are asking what will be the value of A, B and C. Okay. So now I can write, if I just add this F1, F2, F3, then 1 minus 1 plus A I cap plus 2 plus 1 plus B J cap plus 1 minus 2 plus C K cap. That is 0 I cap plus 0 J cap plus 0 K cap. Okay. So the answer is, you can see it is A I cap plus 3 plus B J cap plus minus 1 plus C K cap is 0 and this. So A will be 0, 3 plus B is 0, minus 1 plus C is 0, B is minus 3, C is 1. So A will be 0, B is minus 3, C is 1. So these are the cases to have in equilibrium. So A is 0, B is minus 3, C is 1. So this is the condition. Okay? Okay. Now, coming to question number 3. Yeah, so for question number 3, I just want to tell one thing. Sir has already explained these things in the lecture, but still I just want to tell something so that it will be very useful for this calculation as well. The number of stable and unstable equilibrium points for the potential U are how much? So to calculate the number of stable and unstable equilibrium points and what are the stable and unstable equilibrium points, we have to do some calculations. And what is the calculation? First one is we will take U del U del, as it is a R, it's a function of X. Okay, if it is a function of X, then it will be 0. We will put that one as 0. Then find X values. Then calculate d2u dx2. If d2u dx2 less than 0, this is okay. Now stable and unstable point, right? So it is less than 0 means it's an unstable point. If d2u dx2 greater than 0, that is stable point. Okay, fine. Now our u was what? U, it was written here that 5x to the power 4 minus 10x square plus 1. 5x to the power 4 minus 10x square plus 1. So these are the things. So we will first calculate del u del x. It is 20x cube minus 20x. And I have to put del u del x equals to 0. So 20x cube minus 20x equals to 0. Then I am getting x cube minus x equals to 0. That means x into x square minus x 1 equals to 0. Means x equals to 0, x equals to 1, x equals to minus 1. So I will get 3 points of x. Now I will do del 2u del x2. So del 2u del x2 will be what? See, you can see del 2u del x2 is 60 x square minus 20. Now at x equals to 0, del 2u del x2 equals to 60 x square minus 20 is negative. So at x equals to 0, u unstable, as it has a negative value. Now come x equals to 1 and x equals to minus 1. At x equals to minus 1, del 2u del x2 was 60x square minus 20. So it is 60 minus 20, 40 greater than 0. So at x equals to minus 1, u is stable. Okay. Now coming x equals to 1. Del 2u del x2 is 60x square minus 20. Again it is 40, which is greater than 0. So at x equals to 1, u is stable. So now I got x equals to 0, x equals to 1, x equals to minus 1. These 3 points I got. and at x equals to 0 v is unstable, at x equals to plus minus 1 it is stable. So I am having if u equals to, what was the u? Yes, 5 raised to the power 4 minus 10x square plus 1. Then I will have 2 stable and 1 unstable points respectively. 2 stable, 1 unstable. Now coming here, stable and unstable equilibrium, 2 stable and 1 unstable. So this one is the correct one, 2 stable and 1 unstable respectively. So to summarize this answer, the number of stable and unstable equilibrium points for the potential, we need to calculate del u del x and then put 0, find x, then we will calculate del u del x2, if less than 0 unstable, greater than 0 stable. Okay, fine. Okay, now coming to the next question. At point 1, 1, 2, the speed of a unit mass particle moving in the force field is this one. Find the speed of the particle at point this. Okay, it's a nice question. It's telling that our f is 4x I cap plus 4y j cap. First of all, I need to check it is conservative or not. Simply to have the knowledge it is conservative or not, I will calculate curl of f. 4x, 4y, 0. So now you can see this is 0 minus 0 plus j cap, 0 minus 0 plus k cap, 0 minus 0. So it is 0. So if f equals to 0, and what they are asking, curl of f equals to 0, and given what? The speed of the unit mass particle, speed of the unit mass. So m equals to 1. Okay. At 1, 1, 2 means x equals to 1, y equals to 1 and z equals to 2. And our f is what? 4x I cap plus 4y j cap. Okay. Now we have already shown that curl of f equals to 0. So if curl of f equals to 0, then I can write f equals to minus grad phi or grad v. Yes. So I can write v equals to minus f dot dr. And f is 4x I cap plus 4y j cap dot dx I cap plus dy j cap. So it will be like minus 4x dx plus 4y dy. So 4x square by 2 plus 4y square by 2. So minus 2x square plus y square. This is my v. V is what? V is nothing but the potential energy. Or potential energy I can write. Now, the speed of the unit mass particle moving in the force field this is 3 unit at 1, 1, 2. So at 1, 1, 2, at 1, 1, 2, speed is 3 and our v is minus 2 x square plus y square. So at 1, 1, minus 2 into 1 plus 1. is minus 4. Okay, so this is potential energy, capital V. Okay, now what is kinetic energy? It is half m v square. Half m is 1, v is 3 square, so it is 9/2. So total energy is 9/2 plus potential energy. Potential energy is V. So it is 9/2 minus 4. 2, 9 minus 8. It is 1/2. Now we can see that the total energy is half. And the total energy is conserved in any of the conservative vector field, right? So I got the total energy for another one point as 112 is 1/2. Now we have to calculate at the other point. So what is the other point? Other point is find the speed of the particle at point 0, 2. Okay, so at 0, 2 our potential energy is what? Potential energy is this one. So at 0, 2 means x equals to 0, y equals to 2. So our potential energy is minus 2 into 0 plus 4. So minus 8. And total energy equals to minus 8 plus kinetic energy. So plus half m v square. What type of v? At 0 and 2. That's what they are asking, right? And total energy is always conserved, so it will be half minus 8 plus half into 1 into v square. So v square by 2 is half plus 8. So it is like v square by 2 is 17. V square is 17. Then v is root over 17. Now we need to calculate the root over 17 value. Okay, so it is nearly 4.12. So v at 0, 2 is giving us 4.12. Okay, so let me write here. Okay, so 4.12 means it is very near to 4. This is the answer. Okay? So what we did here, we just check that if is a conservative field or not. If F is a conservative field, then our F can be written as minus grad V. Right? So from there we calculated V at any point, xy point. Then we got the value of V as minus 2 into x square plus y square. And V is a potential energy. Now they are telling that at point 112 the speed is given as 3 and potential is also we can find from this expression minus 2 x square plus y square, and the potential energy is minus 4. Now as speed is given and potential energy is given, mass is also given as 1 unit, then we can directly find the kinetic energy as half mv square, and it is half 1 into 3 square, so it is 9/2. Now the total energy we can calculate kinetic energy plus potential energy. So kinetic energy plus potential energy will give us the total energy as 1/2. Now they are telling that at point 0, 2 what will be the speed. So from the expression of v equals to minus 2 x square plus y square, we can calculate at 0, 2 what will be the potential energy. So potential energy we calculated and it is coming as minus 8. And total energy we have calculated as half. So at 0, 2 point what is the value of kinetic energy. So kinetic energy have the value half mv square, and from there half mv square equals to half plus 8, then v equals to root over 17 and it is coming as 4.12. So the answer of this question will be 4. Take 4 units. 4 units is fine. Nearly 4 units. So this is the answer. Okay. Now coming to the question number 5. Question number 5, a little bit lengthy question, but not that much lengthy. Here, for a force field, if calculate the work done along the paths 0, 0 to 0, 1, 0, 1 to 1, 1, 0, 0 to 1, 0. Okay? Okay, so this is the case. Now for this calculation, let me write here. If is what? If is y square minus x square. Y square I cap minus okay, my laptop is getting bad and minus x square j cap y square I cap minus x square j cap. Calculate the work done along the paths 0, 0 to 0, 1. So let me first write here. First path is 0, 0 to 0, 1. So it is what? It is nothing but x1, y1 to x2, y2. So now you can see here that x1 is not getting changed, like x1 and x2 are same. So dx is what? Dx will be 0. And x is also x1 and x2 all are 0. But dy is what? Dy is some value. It is not equal to 0. So y is going from 0 to 1. Now they are telling what will be the work done. Work done means f dot dr, right? So okay, let me again share my screen. So dx is 0 and work done. Work done is what? Work done is f dot dr. So I can write it y square I cap minus x square j cap. There is something. Let me share my screen again because every time it is getting hang. every time it is getting hang, so I can do one thing. I can just finish my lecture and it will be uploaded, so it will be recorded. So if you have any question, you can just okay, fine. So maybe I can go for finish that lecture. So f dot dr is there. So f dot dr is there. That means it is like dx I cap plus dy j cap. Okay. So now I can write w equals to y square dx minus x square dy. And as we have seen, for this path dx equals to 0. So if dx equals to 0, that means it is only minus x square dy. And y value from 0 to 1, y equals to 0 to 1. But the problem with x, because x has 0 value, so it will come as only 0. So for work 1, that means the first path, the work done is 0. Now coming to the second path. For second path, what is the path? 0, 1 to 1, 1. Okay. So xy, x1, y1, x2, y2. So 0, 1 going to 1, 1. Now you can see here y1 equals to y2 equals to 1. So that means dy equals to 0. But dx is not equals to 0 and x is going from 0 to 1. So what is w here? W is f dot dr. Now what is f here? F is y square I cap minus x square j cap dot dx I cap plus dy j cap. So as I told, dy equals to 0, but so that means it's simply y square dx minus x square dy, and dy equals to 0, so it's y square dx. So y square, y is 1, so that means it will come as 1 integration dx, and it is 0 to 1, so it will be simply 1. Okay. So the w2 will be 1. Now coming for the w3, third path. For the third path, what is there? 0, 0 to 1, 0. Okay. 0, 0 to 1, 0. Here x1, y1, x2, y2. dy is 0 and y is also 0. y1 equals to y2. So w equals to y square dx minus x square dy. Then as dy equals to 0, so it will be y square dx, and y is also 0, so it will be 0. Now we can see that y1 is 0, sorry, w1 is 0, w2 is 1, and w3 is 0. So the answer of this question is the work done along the paths and okay. So actually there is a typo in that question, because there it is given the 3 work done, and here 2 answers are given. The answer will be for 1 it is 0, for 2 it is 1 unit, for 3 it is 0. So this is the answer. Okay, now maybe I can go for the next question. Question number 6. A particle of mass 1 kg falls from rest under gravity with a air drag given by this. What is the approximate terminal velocity? Very good. So mass is given as 1 kg. So falls from gravity, that means from rest, falls from rest under gravity. So v equals to 0 at t equals to 0, and then it is falling. It is falling means the force will be only under gravity, right? And it is mg, simply minus mg if it is y cap. Y cap is up direction, then it is minus mg. So minus mg is how much? Minus 0.2 v square. So minus mg is minus 0.2 v square. V is the velocity. So if it is like that and m is given as 1, so I can write here g equals to v square into 0.2. So v square will be g by 0.2 and the g is 9.8 meter per second square. It is this, then it is 9.998 divided by 2. So 4, 9. So v is root over 49, which is 7 unit. This is the terminal velocity. So 7 unit terminal velocity. Okay, so this is the answer. Now coming for the option here, which one is the correct option? Okay, there is approximate is saying, so if I calculate 2 root 3, no, that will also not come, but the answer is 7. Okay. Here we just calculated that the terminal, so mg, under mg the force is coming as minus 0.2 into v square. So from there we just calculated the value of v. Okay. Okay. So let me share my screen again. So we were talking about this question, right? Yeah, it was there. Fine. We were talking about this question. A particle of unit mass is moving in a potential. What is the positive constant? Which is true at this. So to get the answer, we will just write here u value first. So u is what? It is given as 0.5 x by a to the power 12 minus x by a to the power 6. So what we will do, we will just do del u del x. So what is del u del x? Del u del x is 12 x by a to the power 11 minus 6 x by a to the power 5, and we will just put that one to 0. So if I do that, then it will be 6 x by a to the power 11 minus 3 x by a to the power 5 equals to 0. So 2 x by a to the power 11 equals to x by a to the power 5. Now x by a to the power 6 equals to 1 by 2. So x to the power 6 equals to 1 by 2 a to the power 6. X is a by 2 to the power 1 by 6. Okay. So it's like that x by a to the power 6 equals to 1 by 2. Okay? Okay. Now, x by a to the power 1 by 6. So del 2u del x2. So del 2u del x2 means it is 6 into 11 x by a to the power 10 minus 3 into 5 x by a to the power 4. So it is 66 x by a to the power 10 minus 15 x by a to the power 4. Now they are telling x by a is 2 to the power 1 by 6. Is it a stable equilibrium, non-unstable equilibrium, or what is the value of u? First of all, you will just put the value of u as, you can see here, 0.5 x by a to the power 12. So x by a is this, whole to the power 12. So what will be this? 2 to the power 1 by 6 into 12. So it is 4. Right? So 4 minus x by a to the power 6 is 2. So 0.5 into 2, it is 1. Okay. So no option is correct. So it should be minus 1 by 6, right? If it will be minus 1 by 6, then it will be correct. Why? Because I will tell you. Let's say if x equals to 2 to the power minus 1 by 6 by a. Okay? Then x by a equals to 1 by 2 to the power 1 by 6. Right? So x by a to the power 12 is 1 by 2, 1 by 6 and 12. So it is 1 by 2 square. So 1 by 4. Okay. Now x by a to the power 6. It is 1 by 2 to the power 6 into 1 by 6. It is 1 by 2. So our u will be 0.5 into 1 by 4 minus 1 by 2. So it is 0.5 into 4, 1 by 4. So it will be something like 0.5. No, it will be minus, right? There will be a minus 1. So it will be simply 0.5 divided by 4. So minus 1.125. So it is 0.-125. So of the order of minus 0.1, you can see. So u equals to minus 0.1. And if it is a stable equilibrium or not, for that we will calculate this one. So by seeing the value of u equals to minus 0.1 and all other terms are not correct, so we can see that this is the correct one, stable equilibrium, and by u equals to minus 0.1. How it is coming as minus 0.1? You can see. If I just calculate the value of x by a to the power 12 minus x by a to the power 6, so the u will be 0.5 into 1 by 4 minus 1 by 2, and it is coming as minus 0.125. So it is very near to minus 0.1, so the answer will be stable equilibrium at u equals to minus 0.1. You do not need to calculate the stable and unstable points because the different values are different. Okay, now coming to the question number 8. So find the potential of force F. Okay, I will just do that one a little bit later because it's a little bit lengthy question. Then we will just directly go for the question number 9. Yeah, so for a particle with total energy of 4 units. Okay, let me write here. Yeah, so this is for a particle with total energy of 4 units moving in the potential. So the total energy is 4 and potential is V which is x square minus 3x. Okay, for the turning points. Now what is turning point? First of all, turning points. The turning points are the points where kinetic energy is 0. Now you can see total energy is kinetic energy plus potential energy, right? If it is like that, and I told that turning point at turning points kinetic energy is 0. So total energy equals to potential energy plus kinetic energy. Thus, at turning point, it is mentioned that the total energy is equals to potential energy. Okay? Yes, so total energy is equals to potential energy. So if total energy equals to potential energy, now coming here, total energy was what? 4. And potential energy is x square minus 3x. So x square minus 3x equals to 4. So from there I can get the value of x. So x square minus 3x minus 4 equals to 0. Now I can get x square minus 4 minus 1x minus 4 equals to 0. X square minus 4x plus x minus 4 equals to 0. So you can see x into x minus 4 plus 1 into x minus 4 equals to 0. So x minus 4 into x plus 1 equals to 0, and x equals to 4 and x equals to minus 1. So the turning points are x equals to 4 and x equals to minus 1. Now I can do one thing as well, 4 and minus 1, right? How I can do that one? You can see if x equals to 4, then our v is 4 is like 4 square is 16 minus 4 into 3 is 12, so it is 4, right? And x equals to minus 1. Minus 1 means v is 1 minus 3, that means 4. And v is the total energy. V is the total energy at turning point, that means obviously it is coming as total energy of 4 units. Okay. Yeah, so turning point means obviously where the kinetic energy and potential energy, kinetic energy is 0 and potential energy is equal to kinetic energy, total energy. That is the thing. Now this question: if the force F acting on a particle is parallel to the torque on the particle, if F acting on the particle is parallel to the torque on that particle, then which of the following is or are true? Okay, first of all, torque. Torque is what? Torque is dl dt. And what is L? L is R cross P. What is R cross P? ddt of R cross M V. So if I tell M, then ddt of R cross V. Okay. Now, F is parallel to torque. That means F and tau are in same plane, right? So if f is parallel to tau, that means if I calculate f cross tau, then it will be 0. Okay, so if f cross tau is 0, that I can also see that one. F is what? dp dt. Cross L is what? dl dt. Okay, now we can, so this is 0, right? F cross tau equals to 0. Now f cross tau, as f is parallel to tau, right? So if it is 0 and tau is dl dt, so I can write it ddt of f cross L is also 0, and obviously it's true. So now I can write here dl dt is 0 as f is not 0. So L is constant in time. That means I can write here constant in motion. So L is what? Angular momentum. So which one is not varying with time? That means angular momentum is conserved here. Okay. So one of the example of this type of things where F is parallel to tau is central force. Okay. Now coming to the question. F is 0. No, F is not 0. The linear momentum of the particle remains constant. No. The angular momentum of the particle is constant. That we have seen. The total energy of the particle remains constant. It is not, I can say that one. Because total energy of the particle remains constant of what? Like yeah, total energy is always constant, right? Total energy is always constant. That is also true. It is no longer something we should do for something. But the main thing is that the angular momentum of the particle is conserved. Okay. Okay, now maybe I can go for the 8th question because it was left. Yeah, this one. This one. Find the potential of the field F r square sin square theta cos theta r cap plus r cube cos square theta theta cap. And dr is what? Dr is dr r cap plus r d theta theta cap. So what is the potential of the force? Okay. Let me write here F and dr. dr cap plus r d theta theta. And what is F? R square sin theta cos theta. R square sin theta cos theta r cap sin square theta cos square theta. Okay. Sin square theta plus r cube cos square theta theta cap. Right. So work done is F dot dr. Right? Work done is right? No, potential. We are talking about potential. Sorry. Potential is minus F dot dr. So minus F is what? R square sin square theta cos theta r cap plus r cube cos square theta theta cap dot dr cap plus r d theta theta cap. Now you can see that r dot and r cap, like r Actually it is dr r cap. Yes, dr r cap. It's not dr cap. It is dr r cap. So dr r cap. So it is like minus r square sine square theta cos theta dr, because r cap is 1 plus r to the power 4 cos square theta d theta. So minus r square sine square theta cos theta dr minus r to the power 4 cos square theta d theta. Okay, so minus, here it is only the integration is only on r, so it will be r cube by 3 sine square theta cos theta minus r to the power 4. Theta will be, it is on the on theta integration, so it is half 2 cos square theta means 1 plus cos 2 theta d theta. So minus r cube by 3 sine square theta cos theta minus r to the power 4 by 2. It is theta plus cos integration is sine 2 theta by 2. So it will be like minus r cube by 3 sine square theta cos theta minus r to the power 4 by 2 into theta minus r to the power 4 by 4 sine 2 theta. So if I see the answer for the potential of the force, so it is like r cube sine square theta cos theta plus constant, or r cube cos theta plus a constant or something. So it is coming as r cube 3 minus r to the power 4 sine 2 theta. So this is a final answer where this whole term will be our V, potential. And option is a little bit wrong here, so that's why maybe I can write the full answer. The answer is minus r cube by 3 sine square theta cos theta. I think 3 is there. Yes, r to the power 4 by 2 theta, r to the power 4 by 2 theta minus r to the power 4 by 4 sine 2 theta. Like that. Yes. Oh, yes. This is the answer. This is the potential. Okay. So for here, what I did, I just calculated f dot dr, and f dot dr I just calculated like that. F is something r cap plus something theta cap, and dr is dr r cap plus r theta theta cap. So potential is minus f dot dr, f dot dr. So integration will be there, and here integration is only on r. So theta will be come out, and here it is only on theta, so r will be come out. Then so here 2 cos square theta, 1 plus cos 2 theta, then cos theta integration is sine 2 theta by 2, then it is coming as like that. Okay. So these are the questions we were talking about for the week number 2. So I'm just going through the questions again here. All the 10 questions. This is the question. 10th number. Then 9th number is this one. No. Let me first go here. The 10th number. 10th number is this one. To the force if acting on a particle is parallel to the torque on the particle, then which of the following these are true? Then we have already seen that this is the nothing for that. It is for the case of the central force field where force is parallel to the torque. Then we can conclude from there that angular momentum of the particle is conserved, and obviously the total energy of the particle is always constant. So the main thing is that angular momentum of the particle is constant, but the linear momentum is not constant. We can't say anything of the linear momentum, but the angular momentum of the particle is constant. Yeah, that is the thing. Then coming to the ninth question, this is the if proton energy is given and potential energy is given, then what are the turning points? And this is coming as -1 and 4. So this is the final question. Then another question was the Kepler-Tier. So what is the potential minus Kepler-Tier? And this is the stable equilibrium point, which is a stable equilibrium. This will be a -1/6. Then under gravity, what will be the terminal velocity? It will be 7 unit. Then x1, x2, x3. Calculate the path, and the answer will be 0, 1 unit, and 0. Then this is an interesting question, that at point something the speed of the unit mass particle is given. Force field is given and speed is given. Find the speed of the particle at 0.02 point. And the number of stable and unstable equilibrium points for the potential ux 5 to the 4 minus 10 x square plus 1 equals to r. What? Then the other three forces on a particle is in equilibrium. Find the values of A, B, and C. The total net force is 0 on the particle because it is in equilibrium. Then the first part, if which of the following is or are true, so curl of F, curl of E, like that we have to check, and after that we will check. Okay, so these are the case, and these are for the first week. This is first one, this is second one, this is third, fourth, fifth, sixth, seventh, eighth, 9, 10. So these are the questions and the answers. Okay, thank you. Okay. Bye bye.